Hello students, today we'll discuss about powder production methods in powder metallurgy. That topic covers manufacturing process for semester. Powder production methods, there is many methods for making metal powders. The mechanical process are here. The first one machining. That process form the chips by the turning or crushed in powder. That example of this magnesium, barium, Arganium solder, and dental alloys. Second one, shooting. Shooting is the process where the fine stream of molten metal is poured through a vibratory screen into air or protective gas medium. When the molten metal falls through the screen, it disintegrates and solidifies as spherical particles. These particles get oxidized. The particles thus obtained depends on pore size of screen, temperature, gas used, frequency of vibration, metal produced by the method are copper, brass, aluminum, zinc, sand, lead, nickel, etc. Next one, ganning process. That is same as shooting except that the falling material through sieves is collected in water. Powders of cadmium, bismuth, antimony are produced by this process. Second one, physical methods here. In the physical methods here, the electrolytic depositions that used for the producing copper, iron, zinc, tin, nickel, cadmium, antimony, silver, lead, beryllium powders, etc. The metals of high purity are precipitated from aqueous solution on cathode or an electrolytic cell. That copper powder manufactured by solution containing copper sulfate and sulfuric acid and cured copper as anode. At anode, copper positive ions there. At the cathode, the negative ions is there. Iron powder. That anode is low carbon steel and cathode is stainless steel. Magnesium powder, the electrode position from a purified magnesium purified magnesium sulfate electrolyte using insoluble lead anodes and stainless steel cathode. Final deposition occurs in three ways in this process. The first one, a hard brittle layer of pure metal which is subsequently milled to obtain powder, that is iron powder. Second one, the soft spongy substance which is loosely adherent and easily removed by scraping. Third deposition occur in this process a direct powder deposit from the electrolyte that collects at the bottom of the cell. That figure shown here was the electrolytic process for powder production. Next process is automation. In this process, use high pressure fluid jet to break up a molten metal stream into very fine droplets which then solidify into fine particles. In this process, high quality powders of aluminum, brass, iron, stainless steel, tool steel, superalloys, etc. produced. Mechanism for automation. In conventional gas or water automation, a liquid metal is produced by pouring metal pouring molten metal through a Tundis with a nozzle at its base. The stream of liquid is then broken into droplets by the impingement of high-pressure gas or water. The disintegration of liquid stream is shown in next figure that has five stages. The first stage, a formation of wavy surface of liquid due to small disturbances. Second one, wave fragmentation and ligament formation. Third one, disintegration of ligament into fine droplets. Fourth one, further breakdown of fragments into fine particles. And fifth one, collision and collisions of particles. That figures on the various stages of the atomization here, and the low surface tension on the molten metal, high cooling rate, formation of irregular surface like in water atomization, high surface tension, low cooling rates, spherical shapes formation like in inert gas atomization. In this figure, seeing all five stages of the atomization. Atomization is a metal powder forming process. Water automation have a high pressure water jets. As per this figure, the water is used because of high velocity and quenching ability have a water small scale purpose that process used. Gas automation. Gas automation is the use of argon, nitrogen, helium gases in this process. And the third one, centrifugal automation or a rotating consumable electrode automation. In this process, titanium powder can be produced, and the process you can see in figures. Inert gas is insert here and the vacuum by this, and the rotating consumable electrodes at this stage, and non-rotating tungsten electrode here, and that is spindle, and on the bottom the collection pot here of the metal powders. That is schematic diagram of the automation by the centrifugal automation. Automation unit, melting and superheating facility. Air melting, inert gas or vacuum induction melting. Metal is transferred to Tundis, which serves as reservoir for molten metal. Automation chamber. Automation nozzle system is necessary to avoid oxidation of powders. The tank is hosed with inert gas like nitrogen that used for the twin jet nozzle and annular jet nozzle. The powder collection chamber, there is dry or wet collection, need to be cooled for long run operations. Here is various methods of the power production like that. Reduction methods. In this method, hydrogen, carbon monoxide, spongy and porous having uniform size spherical or angular shapes, uh, metal particles produced by this reduction method. Carbonyls. In this method, the metal carbonyls such as ferrous carbonyls and nickel carbonyls that have produced uniform spherical particles with high purity by this process. Precipitations from a chemical solutions produced by the metal powders, and the vapor condensation is a process for the powder production of the metals. Thank you.